All right, in our next setup, we're going to go a little more complicated than you've seen so far. And so let's draw the diagram here. So I've got my transmitter that's sending out 50 milliwatts of power. And again, the signal loss from the cable to the, well, we call it the IR, but I just keep calling it the antenna, is doing a minus 1 dB loss coming through. And then from that point, we know that the access point is using an antenna that's going to add plus 5 dBs. Okay, so I see effectively what the dBs are going to be, so we can get a figure of what we're doing. And so the first thing we have to do is try to convert from our channel. So let's remember what we had. We had that column of dBs, and we had the column of milliwatts, multiplication and division, and then over here addition and subtraction. And at this point it was about the 3 and the 10 to the 2 and the 10. And we know when we start 0 dBs is equal to 1 milliwatt. Okay. So now what we're going to do is try to figure out what, the last time we gave you numbers, by the way, that worked out really easy mathematically. So we have the signal losses, we have the signal gains from the antenna, and so I'm going to start off, as you saw here, first by just trying to draw this example here. And what I'm looking at here is that in the dBm column, well, first of all, we start off by multiplying or figuring out what the 50 milliwatts is going to be. So what I can do to be able to figure it out, because last time we went from 1 to 100, and it was easy because what do? We multiply by 10. So let's just say we multiply it by 10. So then if I did that, I'd be at 10 milliwatts. And when I multiply it by 10, then the dBs are going to become 10. Right? Because I'm just adding, in this case, 10. And then what if I multiply that by 10 again? Now I'm at 100 milliwatts. Well, being at 100 milliwatts, I got a little bit of a problem because I'm only sending 50. But if I did that, then I'd be adding 10 and I'd be at 20 dBs. The good news is I can divide this by 2. That gives me 50 milliwatts. Cool. I'm at the number that I've been provided. If I divide by 2, then I have to subtract by 3. So now I'm at 17 milliwatts. Or I'm sorry, dBs. Let me get the right column and the right name. So now I'm at the starting point here, right? Call that step number 1. I've made it there. So, it was basically an easy way to get to that initial setup. Again, I got another problem. I'm subtracting my dB loss and adding my dB loss, and they're not using the nice easy numbers that we had from the previous example. So how do I then get rid of 1 dB? I mean, I know I could say, oh, let's just do minus 1. But if I do minus 1, I'm then at 16, and I don't have any rule of 3 and 10 that helps me with that, do I? So I have to figure out how to get to the 16. And so what I'm going to do is I'm basically going to do some more math genius work. I'm going to subtract 10 dBs, leaving me at 7. If I subtract, then I have to divide by 10. So that leaves me at 5 milliwatts. Okay, neither one of those are the numbers we want. We wanted just to subtract 1. But what's really cool is I can add 3 a lot of times, and 9 plus 7 is going to get me to that number 16 dB, which is where I wanted to be, subtracting 1. So if I added 3 times, then I'm multiplying this by 2, so it becomes 10. Another multiplication, which becomes 20. Another multiplication of 2, which becomes 40 milliwatts. I hope you saw the example of how I'm trying to set that up in here. Okay, now we have the next problem of adding 5 dBs. So again, we could do a similar type of step, knowing what would it take to add 5. I want to get to the number 21 dBs. And so if you can think about it, we could add 10, then we'd be right there equal to 36. and then we need to subtract enough so that we get to 21. So, well, let me do a little quick math here. Minus 21, so that's 5. So I need to subtract 21 or 15. I'm sorry, I have to subtract 15 decibels to get to that number. And fortunately, 3 times 5 would be 15, so I subtract 3 many times. You notice I'm running out of room. I should have planned this a little bit better. So what did I do? If I start off here, plus 10. So plus 10 means that I'm multiplying this by 10. So now I'm at 400 milliwatts. The next plus 10 is another multiplication of 10, so I'm at 4,000. Now that I'm at 4,000, I'm going to subtract 3. Subtracting 3 means I'm going to divide by 2, so I'd be at 2,000. Subtract another 3 again, I'll be at 1,000. Subtract 3 again, I'll be at 500. Hey, we're almost done. So another one, right? Another 3, I have it again, 250. Do another subtraction, one more halving. I'm at finally an answer of 125 milliwatts with that total then of 21 dB. Okay, remember it's not the most accurate way of doing this mathematics, but it's certainly something that's important for us in trying to determine, again, things like the coverage area.